So remember last time we were doing this example, right? Where, you deposit $100 into an account, and the account is earning 6% interest. It's compounded monthly. But notice this is actually very different because we're not just depositing once and then that's it. We're just leaving the money alone. It's actually a little bit more realistic in that we're doing many deposits. We're actually depositing each month, okay? We want to know exactly how much will be in the account 15 years later. We did get that last time, right? I actually showed you using the formula. I also showed you using the TVM solver. And either way, we got the same amount, which is $29,081.87, okay? Now, that's what we got last time. We're gonna look now, we're gonna figure out now how much, parts B and C, how much total money we put into the account and how much total interest we earned. Remember, the account's being compounded as well, so there's gonna be interest in there. All right. This amount here actually includes not only how much we deposited, but also interest. That's what this also includes, interest. So how are we going to do that? Well, again, let's figure out how much we put in total. How much we put into the account in total. Whatever's left over came from interest. Well, we're doing $100 per month, right? For 15 years, okay? So basically, we got to figure out how many months that is and multiply by $100 per month. So we have $100 per month. We know that there are 12 months per year, right? 12 months per year. And this is going on for 15 years, right? So it's just like that factor label method in the very beginning of the course, right? Some units are going to cancel. We're going to have this cancels with this, right? Year and years cancel. Months, and month cancels. All we're left with is 100 times 12, $100 times 12 times 15, which turns out to be $18,000. Now that came from us, putting money into the account. Now the question is, okay, well, how much came from interest then? Well, if this is how much is in the account, this came from us. What's left over came from interest. And so we subtract and we get this, right? This is how much is in the account in total. This came from us. So we're basically throwing that away. Whatever is left over came from the interest. That's this. Okay. So that's what we get here. Are there any questions about that? Okay. Now here's another one that's very similar. Suppose we want to have $500,000 in a retirement account for 20 years, in 20 years. So, basically we want to have $500,000 in an account 20 years later, and the account we know is earning 10% interest, so it is compounded. How much do we need to deposit in the account each month? So this one's a little bit different because we're looking for the monthly deposit, how much we would have to put into that account each month. Notice also it's being compounded monthly because remember, we're assuming as often as we're making deposits, the account is being compounded. And then we'll figure out how much total money is in the account and how much total interest do we earn. All right, so what I'm going to do first is show you how to solve this using the formula Then we'll go through that TVM solver. Okay. All right. So we have seen the formula last time, so I didn't reproduce it here. But A, remember, that's the balance in the account. And this is what we know. We actually know this is $500,000. We're looking for the regular deposit, which is what PMT is. Okay? That's what we're looking for. PMT, that's our regular deposit, which is unknown. That's what we're looking for. Excuse me. R is the annual interest rate, but you express it as a decimal here. So in the problem, it was 10%. As a decimal, basically as a decimal meaning as you move the decimal point to the left 2 spaces, so it's 0.10. N is how many compounding periods there are in a year, which is 12. Because again, since we're making monthly deposits, that means it's being compounded monthly. And T, that's how many years this is going on, right? And we're assuming 20 years. Okay, so we put it in the formula again. It's on the notes from last time. But this is what you get, and you want to get your PMT. Now, I'll say it here also, but I'll say it again as well. You really want to work with the innermost parentheses first in the numerator and denominator. So here you want to do 0.10 over 12 first, and then add 1 to it. And I think that's actually, yeah, what we do here. See? You want to do the innermost parentheses first. Work your way inward towards outward, if that makes any sense. And then, of course, we do the exponent. Okay, so that's what we do here. We have 0.10 over 12 is 0.008333. Then we're adding 1. Okay, that's how we get the 1.008333. And again, we're doing the numerator and denominator separately, but we did do 0.10 over 12 down here as well. Then remember, order of operations, right? Exponents come next, so we get 240. And we raise this to the exponent, and we get this. I know it's a lot. I mean, personally, I like to use the TVM solver. That's just me, though. But I'm showing this in case people like to use the formula, and that's fine. And then we subtract 1, right? Again, parentheses first.